Wildcard masks come up when we're working with EIGRP, OSPF, and access control lists. Now, for OSPF, we are demanded to have a wildcard mask in every single network statement. We cannot get by that if we use the network command. And there's intricacies to any wildcard mask. We want to be able to read these. Let's make sure we can do that. So the way we read wildcard masks is, first, understand that they are a range operator that represent the beginning IP address and the ending IP address by which this command applies. So how do we find the beginning of the range? Well, the beginning is just the IP address that is supplied. Nothing more, nothing less. The ending of the range is the product of adding each octet of the two dotted decimal values together. So add first octet to first octet. The sum is the end IP address first octet. And then repeat again for second, third, and fourth octets. So let's do this down below. We'll add the two. And this will reveal to us the end of the range. The end of the range is 10 plus 1 plus, or 10.1, 0.98, all the way through 135. So the place where we had to do a little bit of thinking is the final octet. We'll write out the range completely. And so this OSPF network statement says, enable OSPF for area 0 for any interfaces which have an IP address within this space. So the challenge was, what do we do with the .7? And the solution is figure out the end of the range, work out that entire space, and then do maybe a show IP interface brief and find what local interfaces on that router fall within the range. Let's make sure we are good with wildcard mask interpretation for OSPF. We've got the IP address that's supplied, which is the first IP address that we are given, all the way through the sum of the IP address that's supplied. And all we have to do is really add 8 and 3. 8 plus 3, you know it's 11. That gives us the ending of this range. And now we can look at our router's interfaces and find what exists within this space. You might think, well, why might we do this? Well, I prefer using .zeros in the real world to make sure all zeros. Pin down the exact interface IP address. However, I'm going to say however, if we want to get tricky, and let's say we've got a /30 mask, this would be the equivalent. So someone might have said, I don't necessarily know if I'm going to have the first or second IP address in this subnet. Let's make us immune, and the syntax would show us that. The syntax would allow for that. So it's very powerful, the concept of a wildcard mask, but that power means we do have to do a little bit more work in the reading of configuration commands that use that logic.